Before we go over your Chapter 19 warm-up, I want to just kind of think back to the new wording that we learned yesterday. See if I can't really solidify the difference between what we learned yesterday about confidence level versus what we have already known about confidence interval. So, interpreting the confidence level has to do with how many of a whole bunch of intervals, and the size of those intervals. Okay? So interpreting the level will not actually have the numbers that you put in your interval. So interpreting this will not actually have these numbers in the interpretation of confidence level. Yes, so we're saying something like this. How many? About 95% of them. Okay? And what size? The 95% confidence interval size ones. Yes. 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 These will always match. They have to. Because if you have a different size interval, if say you have 90% size intervals, then that will make only 90% of them, about 90% of them going through the thing. So, okay? And if you have 99% size intervals, that's bigger, so you'll have more of them containing the true proportion. So those always match. Okay. So for this problem in context that we're about to go over, it would say something like about 95% of all 95% confidence intervals contain the true proportion of this professor's students who are registered to vote. So I wanted you to also emphasize that this is inference is always about the present or the future, not who were registered to vote. It's who are registered to vote. We infer about now or the future. We don't need to infer about the past. The past has happened. It's done deal. Okay. Now, okay, let's see if I can't you don't have this problem. We're just going to practice with this real quick. This is a problem about the proportion of all cars that have at least one safety violation or considered unsafe. And you're going to make a 90% confidence interval. So I want the odds to tell the evens, the interpretation of 90% confidence level in context of this problem. Okay? Do that. Interpret 90% confidence level in context of this problem. Go.
Nobody's here.
Okay, what are you going to tell me? How many? How many?
Oh, 95%.
No, it's a 90% confidence. So how many? About
About
90% of what?
confidence interval.
Of 90% confidence intervals. Yes, they have to be that size. Contain the true proportion of drivers. Da, 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 da. All right. Okay, so let's check. This level interpretation, level interpretation would have said how many? About 90% of them. Of what size intervals? Of the 90% confidence intervals. Contain the true proportion of cars that don't have or have had at least one safety violation, whatever. Now, that's different as opposed to the confidence interval one. The interval one is the one we put at the end of our panic model, where I'm 90% confident that the true proportion of unsafe cars to go through the auto thing is between 6.1 and 14.8%. That's interval, because this is giving me actual interpretation of a numerical interval. Okay? Let's do one more so the evens can tell the odds. So let's see here. We're going to do this problem. So this problem is about the proportion of teenagers who typically go to the movies on a Friday night. And I want the evens to tell the odds, the interpretation of a 95% confidence level in context of this problem. Okay, go.
95% of the 95% confidence interval contain the true proportion of the
Boom. Got it. Okay, very good. I'm hearing it. How many? How many? About 95%. Of what size intervals? Of the 95% confidence intervals contain the true proportion of teenagers who typically go to the movies on Friday night. Okay, very good. Let's now finish out going over your warm up. Here we go. Warm up. Page 26 in this packet. Page 26 in this packet. Here we go. All right. When you do a panic model, okay, you do not have to write PANIC over to the side or whatever. That's just to help a mnemonic device to help you. But let me tell you this, because I've seen this little bitty mistake made lots, and I'm trying to heed that off. So I put a P here just to tell me I need to do my parameter. The P that I put right here, P equals, that's not for panic model. This P is a variable representing a number. So it needs to be P equals the proportion of this statistics professor students that are, everybody look right now at what you wrote, see if are registered to vote. What's wrong if you put were registered to vote? Yes, you infer about now or the future. You don't need to infer about what already happened. Okay, A is for the assumptions. Do not just put random stated. Nope. Randomly selected students was stated. Okay, randomly selected students was stated. Independent, 50 is less than 10% of all this professor's students. Why do you think they told you 700 students was the size of her student load? So that we would know that 50 is indeed less than that, because, for example, I only have 150 students. So if I only have 150 students, what am I limited on? What's the most I could sample? 15. She has 700, so what's the most she could sample? 70. Okay. All right, moving on. Large enough for proportions is 10, so that's at least 10 successes, so 35 were registered to vote, and at least 10 failures, 15 were not registered to vote. You could have also gotten those numbers basically by doing n times p hat, and n times 1 minus p hat, same thing as how you got the 35 and the 15. Normal model applies. All right. That's the P and the A of the panic model. The N of the panic model is to name the interval. This is a hyphen. These are not subtraction signs. This is a 1 hyphen proportion. It's a 1 proportion Z interval. And that's all you know at this point. We will do like about 10 other things, but we work at them one at a time. And we'll keep them all straight as we go along. So it's a 1 proportion Z interval. All right, then the next is doing the formula for a confidence interval. And I wanted to remind you on your formula chart that you picked up, on the back of it, right up there at the top of the back, is this formula. So this formula for confidence interval is where you have your statistic, and the statistic is the p hat, plus or minus. The critical value is the Z star, and then of course this standard deviation of the statistic is that p hat 1 minus p hat over n. Okay, so that's where that formula is if you do not have it memorized, and that's fine. And so then here, let's see, let me go get that going on there. So here then the interval went from about 0.573 to 0.827. I'm 95% confident that the true proportion of the statistics professor's students who are registered to vote is between 57.3% and 82.7%. So what would happen, now they say according to a September 2004 poll, about 73% of this kind of student, I guess, is registered to vote. So do you think that we have evidence based on that interval? Does it appear as though her results are different than the nation? No. Why does it not seem, does not give us evidence that hers is different than the nation? Very good, because 73% is in the interval. Now, I'd like to think about some other numbers. Suppose the national number had been told to us to be 0.58. So think about this for a second. I'm going to ask you it in a little different way. If the national poll is 0.58, does this give evidence that the proportion of her students registered to vote is higher than the national average? But a whole bunch of the interval is above, most of the interval is above 58%. Doesn't matter. It does not matter. If this is anywhere in the interval, it is a possibility. You cannot say because a whole bunch of the interval is above it, it's likely that it's higher. No. No. 58 is in there, so 58 is a possibility. Okay. All right. So I wouldn't have evidence that her numbers are higher. What happens if the population parameter had been 52%? Then what would we do? We have evidence that hers is higher than the national average? Do we have evidence that hers is higher than the national average? Oh, man. Go ahead. So, but I think I had some blank stares here. Let me say this again. What if the 2004 Gallup poll said, nationally, about 52% of all 18 to 29-year-olds are registered to vote? Is there significant evidence that her students are registered to vote at a higher rate than the rest of the nation? That answer is yes. Because why? Yes, the entire interval is above the national average, so that seems with that particular confidence or whatever that we would have evidence that her rate is higher than the national proportion. Okay. Did I? Yes, ma'am.
What would be like the correct way to write that?
Okay, so if this was the thing, if that was the number, okay, so then I would say there is evidence that, if that was the national one, there is evidence that her registration rate is higher than the national average. So that's what we could do if that's, because the whole thing is higher. Okay, last problem, here we go. This one is asking you to solve to have a small enough whisker size, a small enough margin of error of 0.04 with 95% confidence. Okay, now will you check your math and see if you heeded this information from the September, look, it says, if the professor only knew the information from the September 2004 Gallup poll, that means this is all that is known. Okay. 0.73 is all that is known. That changed this. So your standard deviation then is the 0.73 times 0.27. So that's a small detail, okay? Small detail, but that's part of what I'm teaching you. Pay attention to those little small details. Okay. And so if you mathematically solved this, you would always round up. 473 is not big enough, so you round up to 474. Okay, so in order to be this accurate with this level of confidence, she would have to sample 474 of her students. So now this isn't part of the question, so I'm extending this for you. What is that? Is that possible? Is that going to be reasonable for her to do? Why not? 474 is going to then start violating some conditions. Namely, which one? The independence. Because we already said, you guys did a good job earlier of telling me, because she has 700 students, 70 is the most she should be allowed to sample. So Not that you were at, yeah, that's way over. Notice that so she's going to have some concessions. She is not going to be able to be this accurate with this level of confidence. She's going to have to back off with something. Okay? All right, so that's what you play with there. So any other questions on the warm-up? Then we will quiz. Now,